Hey guys, I just wanted to go over your heat energy quiz answers. You can see by the average score, 89%, you guys did really well on this. So I just wanted to give some kind of feedback in case you did miss one or two, just so that you knew what you missed. Okay, so number one is the following process endo or exothermic. You have something that's being dissolved in water and the solution gets colder. Whenever you have a solution getting colder, you have endothermic. It's actually pulling heat from the surroundings to get that reaction to move forward. And you actually feel that by the reaction getting colder. So if it gets colder, your answer is endothermic. So nice job on that one. If you have natural gas methane burned in a furnace, that's going to be exothermic. Anytime you have exothermic, you have something that feels warm because it's actually releasing heat. So fire, anything burning will always be exothermic reaction. And again, you guys did well with that. This asked about endo or exothermic just based on your heat of reaction, your delta H. You can determine if it's endo or exothermic based on the sign. So because this is negative 67, your answer is exothermic. If that were a positive 67, then it would have been endothermic. But this is exothermic because it's a negative delta H. Again, that's releasing heat. So that's how you can determine if it's endo or exo when you're given the delta H. Okay, you can also tell based on where it's at in the equation. So in this case, my heat, whatever my heat was, it's on the reactant side. And whenever you have heat on the reactant side, it is an endothermic reaction. Okay, if it were on the product side, then it would be exo. But because this heat's on the reactant side, it's endothermic. This is a specific heat problem. So I gave you the equation. So Q stands for your heat energy, mass in grams, specific heat, and then your delta T, your change in temperature, which is just your final temp minus your initial temp. So in this case, just plugging your stuff in and knowing where to go from here. So 585 joules, there's your heat energy. So it's 585 equals the mass, 125.6 grams. Specific heat's what I'm calculating, so I don't know this right here. And then I'm going to just take my final temp, which is 53.5. I'm going to subtract 20. So this number is 33.5. And when you multiply 125.6 by 33.5, and then you're going to take that number and divide it over to find your specific heat, you get 0.14, okay, which is joules per gram degree Celsius. Okay. This is also a specific heat question. It asks you to determine how much heat is actually being released. So it gave you your specific heat, 0.21. It gave you your amount, which is 5 grams, and it gave you your temperature change. Okay. So because this is releasing heat, technically I will accept either answer. 52.5 is the answer because it's asking you how much is released, 52.5 joules. But because it's being released, it is a exothermic reaction and that's negative. So I know some of you also gave me that negative 52.5. So I accepted it either way because technically speaking, that's what's being released. So either way, I'll take that. So you have this much joules that is being released because it is it's a negative, it's a exothermic reaction. Okay. Also another specific heat problem. Again, it gives me my specific heat, 0.39, which is going to go here. It gives me my mass, joules, my heat, which is in joules right here. So this is 200, and my mass is 10 grams. So if I just multiply 10 times 0.39 and divide that over, I get my temperature change, which is 51.3 degrees. Okay. I'm going to look at that one because I think that there are some answers that are probably correct. They just didn't get rounded correctly. So I just wanted you to have feedback on what that was. But that is your answer, is 51.3 degrees. So I'll look, I'm going to regrade that question, but I wanted you guys to see what the answer was. Okay, high specific heat. This is just understanding what specific heat is. So specific heat by definition is the amount of energy it takes to raise 1 gram of any substance by 1 degree Celsius. So if you have a high specific heat, it means that it takes a lot of time to get a temperature change. So it's going to take a lot of energy and a lot of time. So if something is a really high specific heat, you're not going to see a temperature change as quickly as you would with something with a low specific heat. So, for example, if you guys have ever gone to the beach in maybe May, okay, well, maybe it's in Florida or wherever you're at the beach, it's warm starting in April. I mean, it's warm all year round, but it's really, really warm. And so you would think, well, by May, if it's warm enough outside, it's in the 80s, surely that water is going to be nice and warm. But water has a very high specific heat. So that means that it's going to take a lot of energy from the sun, a lot of that heat energy, in order to see a temperature change. So even though the air feels, 85 degrees outside, that water is going to take a lot of extra time to become warm and to feel that temperature change. So let's fast forward that a little bit. Now let's say that you go to the beach in October. Okay, so Florida's still relatively warm in October. I know that in Ohio, sometimes it snows in October, but Ohio and Florida are obviously very different. So Florida is going to be still relatively warm, maybe not in the 80s, but if you've ever stepped into the ocean in the fall, it's actually still relatively warm. Okay. Why is that? Because water has a high specific heat. It means that it's going to take a lot of time to see a temperature difference. So it's pretty much had all summer, all of that heat energy from the sun to warm up. So it hasn't really cooled down yet, even though the temperatures outside are starting to cool. That water is going to be resistant to change that quickly. So when something has a high specific heat, it takes a lot of energy and more time to see a change in whatever energy or whatever the temperature is. Okay. So I'm actually going to skip this question for a second and go down to here because this kind of goes along with that. So for a skillet used for cooking, do you want a high or a low specific heat? Okay, I want a low specific heat because if it's low, it means that it's going to heat up really quickly. You don't want to be trying to make scrambled eggs and you're waiting 40 minutes for your pan to heat up. So when you're cooking, you want low specific heat. Low specific heat means that you have the same amount of energy, but it's going to change a lot faster. Okay, so it's going to heat up quickly. If I had a high specific heat, I would be standing there for a very long time waiting to see when my pan heats up. Okay. So low so that it changes quickly is your answer for that one. Okay. And then the last question I'm going to go over is this is an energy diagram, and you had to determine whether it's endo or exothermic. It's exothermic, and you know that because your products have less energy than your reactants do. And if you think about this, when you have an exothermic reaction, you're releasing heat. Heat is a product. So if you're releasing that energy, it's going to make sense that their products are going to have a lower energy amount than the reactants did. Okay, if this were flipped, then it would be endothermic because the reactants would have less heat than the products do because the reactants are going to pull that energy in to move it forward. But because the products on this graph are less than the reactants, this is exothermic because that energy was given away as a product. So it's losing energy essentially. Okay, so those are the answers to this quiz. I just wanted to make sure that you guys had some feedback as far as this goes. I am going to look at that one quiz and see and look at the questions on that. But other than that, I just wanted to give you some feedback on that. So hopefully that helped. And if you have any questions, don't hesitate to let me know. All right, guys, thanks.